So far, so good. Second keynote. Behind us now. Relax. So we're just going to keep moving on. So I'm between you and Chris.
Great. Thanks, Dana. Thanks, everybody, for a fantastic day. I was just talking with Dan. I think it's the first time everyone's gotten together in person for some time for this chapter. It's great that we're able to do this, reconnect. I've been to a few different AppSec developer conferences this past year, like a similar story. Everyone's coming back out. They're excited to reconnect, and this is just another fantastic example. What a great chapter. Again, I'm super excited to be here. So the talk today that I'm going to focus on is, again, the OWASP Top 10. We just covered it a bit in Caroline's great talk. And, of course, this is top of mind for many of us. It's a fantastic framework that we can utilize in a lot of different ways. We're going to be talking about serverless as well, and applying the OWASP Top 10 to serverless technology. For those of you, serverless is new for you. It's a good entry-level piece. If you have some deeper questions, we can dive into those as well. But definitely excited to talk about the topic today and jump into the OWASP Top 10 for serverless. So just to get rolling here, I'm curious, how many Beatles fans do we have in the audience today? Oh, we got a few. Okay, that's good. Good to see. How many people have heard of the Beatles? Much better. All right, so if you've heard of the Beatles, you might know about this. If you're a Beatles fan, you definitely know, but there was a documentary that came out last year called Get Back. It's by one of my favorite movie producers, directors, what does everything, Peter Jackson. And if you didn't get to see it, that's okay. So I'm going to talk about it a bit. But if you did see the documentary, you got a really great insight in super detail about the Beatles at the end of their career. There's all kinds of rumors around that they're going to break up, and there was all this drama going on. But it was like in the media and the news in the late '60s, right? So what was true, what wasn't true, right? But if you watch this documentary, you see exactly what's going on. You get to see John and Paul going at it. George Harrison quits the band. Yoko's not happy. Linda's not happy. The drama was real, and I thought that was a really cool part. Maybe not cool, but really interesting part about the documentary. Is you really got to see it. I'm like, this really happened. But the other part of this documentary, and if you're a music fan, and by the way, if you live in Portland, if you're not a music fan, I feel sorry for you, because there's so many amazing music venues and artists in this town. It's incredible. But the other part about the Get Back documentary is you get to see how the Beatles write their songs. And even later in their career, they had all this success, right? All this success. And a lot of their songs had all these different layers and orchestral movements and backwards messages and all kinds of stuff going on, right? But if you watch this documentary, you see John and Paul there's a little idea that they took, right? It's 3 chords and the truth. It wasn't very complicated what they used to create their songs. Just a very simple idea, and then they iterated on that idea. They built some of their, very famous songs, but it started with a simple approach. And I think that's the great thing about the OWASP Top 10. And look at some of these frameworks, you're picking a framework, the OWASP top 10 being a really good one, is that it keeps it simple, that you can say, okay, this is a baseline that I can work with and iterate from there. So a bit of a theme for the talk here, just to get a bit of a musical analogy here, but I thought that was a great part about this documentary. So just a quick background about me, and I'm getting a lot of mileage out of the shirt, by the way, so I realized that. But my name is Chris Koehnecke. Last name is difficult to spell and say. You just call me Chris. And I'm the VP of Security Engineering and CISO in a company called JIT. JIT is an acronym for Just in Time. We're a cloud security startup, developer security startup company based out of Tel Aviv, Israel. And prior to joining JIT, I've been there for about a year as the CISO and VP of Security Engineering. Prior to joining JIT, I was with KPMG and did Big Four consulting for 15 years. And I actually led our cloud security compliance practice, which basically meant that we took, like Caroline showed some of the big companies in that graph, and even smaller companies, we take them through these cloud compliance processes, right? So if you guys know FedRAMP, you know SOC 2, you know ISO, there's other like in-country regulations in Japan, Australia. You know, if a company wanted to get through a regulatory process, you know, we'd bring a KPMG, we'd bring a team on board. You know, we had great success, fantastic success. I like to say we were the best kind of FedRAMP consulting team out there. Really helped to open up new markets for our customers. But a lot of times it was more of a business, right? Like, hey, let's get this certification so we can sell. And the security processes that we would bring, the tooling that we would bring, it worked. We got compliant, but it would often stifle developer velocity. And too often, we'd see that the creativeness for these companies, the new features, the development cycles, the developers would leave in a lot of cases. It's just frustrating, right? Because some external parties bringing in, these tools and processes, and as a developer, it's just not, your job has changed. So there was the flip side here, but the really good part of it, of like achieving an objective and getting compliant. And the other side of the house, where it was, hey, the company is not, the client that we're working with, they're not going to be as competitive because they've lost that competitive edge, because they've lost that developer edge, if you will. And again, I'm also curious, any consultants in the room? I'm not trying to badmouth consultants, but because it's a great gig again. And there's also, we talked earlier about, there's discussions about getting into cybersecurity and like different ways that you do it. Consulting is a great way to get in, actually, because you can start. I started at the associate level at KPMG. Not knowing a whole lot about cybersecurity, a long time ago, and just finding ways to provide value, and you can work your way up, you can learn quickly. So consulting is fantastic, but at the same time, one of my clients, during my consulting career, talked about, hey, we want to really empower developers, and that's been a lot of discussion, today and comments, and I think we, hopefully all of us agree with this, but the more that developers own security, the lower the risks are going to be present in environments, with companies and software providers, and the more the developers are going to be part of the culture, right? Part of the it's not just, hey, the pen test report got thrown over the fence, all right? And here we go again, right? It's, hey, developers can own security, and that's really what we're trying to do at JIT. And that's why I left KPMG and joined JIT. And of course, the startup world is very fun. I can also share that I am the first U.S. employee for JIT. Just a bit more background there, and that's been a lot of fun. I've been able to go to Tel Aviv 4 times now. It's an incredible place. Just the technology there, kind of tech hub, the cybersecurity. I mean, they're so passionate about it. They're so just an amazing place to go experience and learn so much, just in 1 year working with the company. But that's been fantastic. Actually, I brought some swag back. It's directly from Israel. So after the talk, if you'd like a water bottle or a bag, feel free to help yourself. But that's enough about me. Just a bit more about this. Why are we credentialed to be able to talk about serverless and talk a bit about the OWASP Top 10. Is that our product is based 100% on serverless. Just to give you like a real simple example here of our environment, right? We've got our our AWS environments, we've got our GitHub environments, we've got our whole orchestration engine with this built 100% on serverless. Then we have our security tools that are part of our CI/CD, and we have our third-party integration. So it's kind of a very simple diagram, if you will. That shows a bit about how our product was developed, but we're all about looking to make having developers own security and supporting bringing in these security tools into the development processes. All right, so the OWASP Top 10, and I think this is pretty cool. And there's been a lot of discussions today about like different standards and regulations. And while the OWASP Top 10 isn't officially like a standard or a regulation, it certainly is recognized by developers the first step towards more secure coding. And I think that's a good thing, is that developers really appreciate the OWASP Top 10. It's a well accepted. It's like, hey, these are real risks that we need to go take on, and I think that's a big part when you're thinking about aligning with different standards. Do I look at the NIST CSF? Do I look at ISO? Do I compliance, SOC 2? OWASP Top 10 is something that's it's been around for a long time. It's accepted, and and again, developers appreciating it is an important step. And back to the Beatles and the simplicity of how they wrote their songs. And again, you got to see it in the Get Back documentary. And again, there's guys and gals sitting in a room. They're just having fun, right? They're just writing, they're making up stuff on the spot. They're writing songs, they're creating new songs, just real simple. But again, it's that whole 3 chords and a truth piece. This is more like the end product, and not to make you read sheet music, but you've got all these different layers, and again, the orchestral pieces, the backward messages, all those things that, those famous songs that many of us know. But you go back to when they started it, it was, again, just a couple chords here. It's not a whole lot to it. It's not like it's a musical masterpiece that they started with, right? Just a simple idea and built on that. And when we look at serverless architecture, that's kind of, and I showed that previous example of how we're built, but just a simple example of getting started as a SaaS provider, on a serverless environment. You've got these kind of basic components, right? You've got your at the bottom you've got your CloudFront for all your web resources. Typically an S3 bucket behind that. You've got your Lambda functions, where that's the focus, the focal point for serverless. That's doing most of the processing inside your environment, and that's behind an API gateway. And then you've got your Cognito as well for your API calls and authentication and things like that. But just kind of a simple serverless architecture, just to get rolling when we started to build our product that we utilize as a basic framework. And then you might ask, well, what are the differences between classic and serverless architecture? And one big one, and probably the biggest one, is the different shared responsibility model. We'll touch on that in just a little bit, what those differences are. Then serverless functions are ephemeral, right? So they stand up quickly. Lambda functions, you can they have a limited time frame. You turn them on, turn them off, so it's that ephemeral nature of it. There is a level of an increased attack surface on serverless, but you can get more fine-grained control as you configure your Lambda functions. So just some things to think about, and the differences between the classic and serverless models. Here's a bit about that shared responsibility model. And I think most of you guys have seen this, right? Raise your hand if you've seen the shared responsibility. Pretty much everybody, right? That's shame on anybody that hasn't. But if you look at the classic version, right? It's and you look at from a cloud perspective, and I'm going to be focused on AWS, in this talk as well, because we're built on AWS and we're familiar with that's what we use, that's what we know. But the classic version of the shared responsibility model, right? You've got your compute storage database, that's all managed by your cloud provider, by AWS. And then above that line, everything's owned by the customer responsibility there. Also, earlier talk about liability. It's like, hey, I'd rather have the cloud provider take on more liability personally. I think that's a better thing. So, if you look at the serverless shared responsibility model, and you can see that, how the line has gone up, and all the operating system, the network configuration, platform management, network traffic protection, all those things are now managed by the cloud service provider. So that's, I think that's a great thing as a CISO. I like that a lot. I trust AWS and GCP and Azure. And then you're really just responsible for as the customer on that, the data protection, some of these other pieces in terms of just managing your environment. So that, that difference between the shared responsibility model is a big one. And then, back to the kind of the simplicity of it, and we think about, okay, so the OWASP Top 10, and we want to apply the appropriate safeguards. we want to protect our environment. And we utilize this process for a simple way for us to manage our environment and to be able to say, hey, where are the risks that we want to take on, that we want to prioritize, and how do we want to mitigate those risks. So we look at things like, what is the risk, and the OWASP Top 10 can help us understand that. What's the security requirement? We want to validate the data input. How do we want to test that? Like we use open source tools, so OWASP Zap will help us test that scenario and detect that risk. All right, so the OWASP Top 10, we shared it a couple times, today on the talk for good reason. This is something that I think everyone's pretty well familiar with. For purposes of this talk, we're going to do a couple things. First off, looking at the how we look at the OWASP Top 10. One of the things we've done here is we've mapped these top 10 risks to different domains. Because this helps us, again, as you think about the Beatles and the songwriting piece, is like, start simple. Let's put together a set of different security domains and understand how the different risks are applied to those domains. So things like identity and access, that ties to the broken access control, identification and authorization failures. From a code perspective, not surprising, a lot of things there, injection, insecure design, and so forth up on the screen. From a data perspective, your cryptographic failures, software and data integrity failures, that's where those risks lie. For infrastructure, you've got a few things here: insecure design, security misconfiguration, and then logging and monitoring. You also have security misconfiguration, and then security logging and monitoring failures. But we feel like this is a good way, as we look at our environment, we think about these different security domains and how we've mapped to the OWASP Top 10. And then for this talk, you're not going to go through all the different risks, but we're going to focus on some of these more technical risks: broken access control, injection, security misconfiguration, vulnerable and outdated components, and then security logging and monitoring failures. All right, so let's jump into broken access control, and this one, for good reason. I think it's been on the top of the OWASP Top 10 for decades. Things haven't changed, but it's an important thing to be able to mitigate. And again, going through the process is that okay. So it's broken access control, but what are the specific risks that we want to mitigate? Right. So we went through this, and we, from a risk assessment perspective. We want to mitigate the modification or deletion of data, the execution of unauthorized functions, and then bad actor breaking into our environment, wreaking havoc because of the poor access control, and then of course data leakage from cloud storage or databases. These are the bad things that can happen with this broken access control risk. And from a security perspective, there's some simple things, and again, iterate, start small and iterate. Of course, the authentication is super important. We want to have multi-factor authentication wherever we can. We earlier talked about the API authentication as well. Different things we want to do to have strong authentication. And then we want to ensure that our functions are running with least privilege. So we want to have appropriate role-based access control and understand what are those functions, and give them the least amount of privileges that they need to be able to perform those functions. And then we want to perform regular access audit logging, so we know what's happening in the environment. We can detect that if there is any potential malicious bad actor that's broken into our environment and our access controls have failed us. And then here's a few things for detection and remediation of that broken access control. And again, we're focused on AWS here because we're an AWS shop, and hopefully this resonates with many of you. But there's similar services across GCP and Azure as well. But we've got the AWS IAM Access Analyzer, so we can run that. That can tell us right away, do we have appropriate roles across our environment? Where are the gaps? So that can help us a lot. AWS Guard Duty, there's new Lambda support for Guard Duty, so we utilize that as well. And there's also open source security tools. And again, as a startup, this is something that we really value is, we love the open source community, and there's some fantastic tools out there that are open source. So there's a few different tools that we run in our environment to help us understand if our access controls are appropriate. PM Mapper, Cloud Tracker, Police Sentry, and Repo Kit. So kind of a mix of these different tools we can utilize to detect if we have appropriate access controls in place in our environment. Up next is event injection. This is kind of the classic, of course, SQL injection of input data, to be able to have the system perform some type of function bad actors can utilize to compromise your system. And we look at the risks, again, I'm going to follow the same process, right? It's like writing a song. It's like, hey, let's go through first, and from an event injection perspective, what are those risks that we want to mitigate? One is resource exhaustion. We make sure our resources are properly planned. Avoiding things like denial of service attacks. Privilege escalation, again, with the kind of the classic SQL injection example. It's a way to be able to, a bad actor can increase a level of access into an environment. That leads to execution of unauthorized code, so there's the potential with injection that you can, a bad actor, again, can potentially run different scripts and different functions within your environment that they shouldn't be able to do. And then also data leakage, right, is also as a concern, is the potential that we can share confidential customer data or data that's proprietary to us externally. So knowing those risks, coming out of event injection, what are the security requirements that we want to put in place to be able to mitigate those? And one, of course, is to validate and sanitize data within your function handler. And again, the least privilege piece, right? We want to make sure that our functions are running with least privilege. So we want to go through and analyze that. That's another requirement. And then we want to monitor functions at runtime as well. So what are the things, again, that we're going to put in place for detection or remediation of event injection? Again, IAM Access Analyzer, right? So again, this is, from AWS perspective, but we can run IAM Access Analyzer. That'll tell us where there's the potential that we have some roles that are in place that are inappropriate. We can remediate. We can monitor our CloudWatch logs and CloudTrail as well for the potential injection vulnerabilities or exploits that are happening. And then we also want to know if our function is connected to an API gateway, so we can use things like DAS tools. We utilize OWASP Zap for that function to be able to see where we're vulnerable for these types of vulnerabilities. All right, up next is security misconfiguration. This is a really big one. It's so easy to do, right? I mean, I think if you look at some of the different cloud providers and some of those, the different settings that are out of the box, like the vulnerable settings that are out of the box. Not sure why that's the case, but in the end, we want to make sure that we're avoiding those misconfigurations, because things like exposing sensitive data through misconfigured services can happen all the time. So there's a few risks here that we want to mitigate from a security misconfiguration perspective. One is, again, that unauthorized access, right? So we got a consistent theme here. Denial of service attacks and denial of wallet. Denial of wallet's a bit of a new one for serverless that we'll talk about here in a second. Malware and ransomware attacks, right? We want to be able to prevent those risks. And then again, data leakage, another consistent theme here. So what are the security requirements that we want to put in place to be able to prevent these risks? At a high level, proper functions configuration, the max concurrency, the timeouts, the IAM roles, right? We want to have those in place. So here's just a quick example of that denial of service scenario with our serverless environment. And you can see here that you've got your users that are making requests, and then you've got your bots out there that are causing this denial of service situation, slamming your API gateway. And with these AWS functions running in parallel, there's the potential that you can have all these Lambda functions that are that are spun up and that are running. So if you have a long timeout, like a 15-minute timeout, there's the potential for this denial of service, or we call it denial of wallet, where you got all these Lambda functions that are running over and over and over again. So there's different things that you want to do to be able to mitigate that. But it is a risk from a serverless perspective. So what are those detection and remediation steps that we want to do to be able to prevent the security misconfiguration? One is Amazon Inspector. So that's going to help us detect those misconfigurations in our environment. Again, guard duty for AWS Lambda. That's going to be super helpful for us to be able to detect misconfigurations in our environment. Security Hub provides kind of an overall set of security services in our environment that we can utilize from AWS. Also, of course, logging super important. So CloudWatch, different tracing that we're going to do across our environment. And then we're also going to utilize those open source tools. So there's a couple open source tools that we're utilizing, which are Kix and then Prowler as well. I'm not sure if you guys are familiar with those tools, but so it's a good mix here, right? Where we can use those kind of cloud native services that AWS provides to detect those misconfigurations, and then also open source tools out there that we can utilize. So just again, a simple, straightforward security suite that we can utilize to detect these security misconfigurations. All right, up next is vulnerable and outdated components, allowing malicious code to sneak into your environment. And this is obviously a big one with all the supply chain risks that have happened, over the past several years. Very hot topic, and we want to make sure that we've got our software is up to date. We know where if there is insecure software in our environment, we know where it is, and we have a plan to be able to mitigate and update that software. So there's a couple things here to think about from a vulnerable and outdated components. Again, there's a denial of service attack risk that we want to mitigate. There's potential malware and ransomware attacks because bad actors could utilize this vulnerable and outdated software to get a level of access to our environment, and then also data breaches. So what are the security requirements? Very straightforward. We don't want to use dependencies with known vulnerabilities. So that's our key security vulnerability. Security requirement. And then what are the detection and remediation steps that we're going to utilize to be able to determine if our software is vulnerable or outdated? And we're utilizing open source software composition analysis tools. And I think the key here is, we want to pick the right ones, based on the languages that we're using, based off, our environment. So, one we use is OSV Scanner, which is open source through Google, NPM Audit, Nancy, and then OWASP Dependency Check. So a mix of different tools that we're utilizing to detect those vulnerable and outdated components in our environment. Moving on to security logging and monitoring failures. And this is detecting anomalous behavior. And again, the same process here that we want to utilize to be able to determine what different security controls and processes that we want to have in place to mitigate. The risks are undetected and unauthorized access. If we're not logging appropriately, we may not know bad actors in our environment. Delayed detection and response, similar scenario. You don't know what you don't log. And then, of course, the potential for data loss. So from a security requirements perspective, we want to ensure that we have enough and effective logging for our app services. So, like, hey, we're logging all of our administrative events. That's the most important piece there. Starting there is an important step. Ensure you have logs to infrastructure to investigate issues. So logging is turned on, in your AWS environment, your cloud environments, and you're capturing those logs. And then at least having a basic incident response process in place. And what I mean by that is that, hey, you've got a team that's put together, you've got some roles and responsibilities, you've trained up, in particular for a startup like us, kind of a minimum viable incident response process in place. And then go through some tabletop testing as well, right? So you can be able to respond back and go through some sample scenarios just to get everybody on the same page. When a real attack happens, you're ready for it. So from a detection and remediation perspective, and looking at that security logging and monitoring failure risk, from an application perspective, making sure we have appropriate logging, adding application logging for system and admin events, and then we have all the different types of within the logs. It's the content of the logs, timestamp, who performed what, making sure those application logs are meeting our various logging requirements, so we can perform those investigative activities should we need to. And then from an infrastructure perspective, again, focus on AWS, but Amazon Detective, CloudWatch logs, and CloudTrail. But again, just looking at just a baseline step for us from a security logging and monitoring mitigation perspective, this is going to put us in a really good spot to be able to, we know what's happening in our environment, and we can respond, should a security incident and event happen in our environment. All right, so that was kind of going through the different, selecting a few of the OWASP, top 10, and getting a bit to the process and how we're mitigating these risks and getting comfort, that kind of risk assessment approach. And I talked a bit about some of the different tools out there that we're utilizing, and of course, the data services, and if you're on AWS or GCP or Azure, you're likely leveraging those. But there's some fantastic open source security tools out there that perform really valuable functions that can be just as good as commercial tools. And actually, this is one thing that we've done a lot at JIT, is we do a lot of analysis of the tools themselves. We want to understand which tools potentially we're going to see more false positives, which is never good. That security efficacy, the more truly vulnerable issues that are detected, exploitable issues that are detected. That's an important piece there. So we're doing that evaluation all the time as well. So as a security professional, I would urge you is that it's not just a one-time thing. I mean, go through your security tools. Get a good understanding of, are we meeting the bill in terms of finding those real vulnerable issues? Do some evaluation. There's lots of great public resources out there to be able to help you with that. But that's an important step as part of your security program, and then keep doing it, right? Because there's, not surprisingly, tools change, right? Or new tools come out. Or the security efficacy of a tool can change over time. So it's good to keep going just because a tool is good for your environment, or your tech stack may change. So having that ongoing process to make sure the tools are the right fit for your environment is a really important step. And then just a few tools here I wanted to talk through. Again, all open source tools. As a startup, and having limited funding, but also we've done an analysis when we found that these tools are fantastic. I'm curious, this is probably the most popular one, but how many people have heard of OWASP Zap here in the room? Of course, everybody. Perfect. So we actually, if you guys know Simon Bennett's, the founder of OWASP Zap, he actually works for JIT. He joined us around the same time that I did, just about a year ago, and a great guy to work with, and we love Zap. For all the features listed here, just discovering all the different types of vulnerabilities. Works for a lot of different tech stacks and just a fantastic DAS tool to be able to from an external perspective, those web application scans, those API scans. I mentioned this a little bit, but OSV Scanner. This is from Google. We just started using this one. But we like this one a lot because it utilizes this OSV database that Google actually manages, which will tell you, the whole list of software out there and those vulnerable software libraries or vulnerable software versions. And then the OSV scanner itself is just running on the top of that OSV database. So we'll help you detect those out-of-date software packages in your environment. So you can update those or mitigate those appropriately. And then secrets detection, this is a super important piece in terms of detecting, potentially it happens, right? We inadvertently or potentially maliciously, secrets, different API keys and and tokens are potentially in our code, in our environment, we're utilizing Git leaks, within the code itself. We like Git leaks a lot because it detects these different types of secrets. It'll go back within our GitHub, within our Git history, and detect those vulnerabilities, and then it's easily integrated into our CI/CD. So again, another open source tool, free to use, but we've had a lot of great success with Git leaks. And then Prowler I want to talk about because from an OWASP top 10 perspective, we talked about that security misconfiguration, and that's a really big one. And Prowler can help us with the runtime infrastructure misconfiguration. So it's got a lot of different checks. 200 plus checks, different output formats that you could utilize with Prowler, supports for AWS organizations, and now it also supports, I think there's a new version that just came out, version 3, that supports Azure and GCP as well. So it's a great cloud misconfiguration detection tool. All right, so I think running near the end of the talk here, and hopefully this has been helpful just to kind of think through, as you look at the OWASP top 10, like what's the process that you're going to go through to be able to understand what are the risks based off of the statement from the OWASP top 10, what are the risks that we want to mitigate based off of our environment, our tech stack, and then what are the steps we want to take to be able to reduce that risk. But again, looking at this, in terms of securing our serverless app, starting with that framework. And again, loving OWASP serverless top 10, is a great baseline, a consistent baseline that we can utilize. There's some other good ones out there, and again, as an AWS shop, we like the AWS startup security baseline. We look at that as well. There's a CIS AWS Foundations benchmark that we utilize, and there's also an AWS well-architected framework. So, but I think the important point here is to pick a framework with those prescriptive controls and utilize that to be able to drive your security program. And then you want to make sure that you're monitoring your program in your application environment over time. And just the last thing I'll say, just about our product. I talked a bit about how we constructed our environment. But if you look at our product itself, again, it's empowering developers with security. So all these different layers, security domains, whether it's your application security, your CI/CD, cloud security, or DAST, you want to be able to run all these checks all the time, right? So that's what that's the product that we built at JIT is a security orchestration platform. Because at the end of the day, you might pick different tools. Like I walked through some of the tools that we like, and also some of the different native services that we're utilizing within AWS. You're probably going to have your own tools that you like, or you may just want some help and some suggestions, which of course we'll happily help you with. But we want to make sure that we're running these checks at all the appropriate times. At the beginning when developers are actually developing in their IDE, then within the CI, within the CD, you're running those appropriate checks, and then also runtime. So that's a big part. We look at our security program. Running those checks on a continuous basis is a super important part of the security program because you can construct your environment, you can build it the right way as you start, but there's going to be configuration drift over time. You want to be able to detect that, and that continuous security approach is a super important step. All right, well, I think I'm running near the end of time here. Just take a quick time. Yep, just wrapping up here. But you look at this. For us at JIT, it's just kind of the beginning, right? We think about the different security layers, the different tools that we're running, and running those tools, on a consistent basis. It's similar to Peter Jackson. He keeps iterating, right? He keeps getting better and better. I heard there's back to the Beatles. I heard there's another movie that's coming out. He found some long lost footage somewhere in some dark cave that he's putting together for the next documentary. But he's always iterating, and I know that we're all doing this in the room, right? Always looking for new and innovative ways to be able to mitigate risks. You'll have more secure services and applications out there. We're going to keep iterating as well. So with that said, I think we're at time. I don't know if I have time for questions or not, but happily talk with anybody about the different security tools, our practices for securing our cloud native applications and looking at serverless. But again, just I can't thank everybody enough. What a great day. Different talks, so much learning here. Really enjoyed it. I know we've got a little bit more to go, but thanks everybody for your time. And then the last thing, if anyone doesn't want any swag, feel free to grab something.